Alright, in this question here, we are asked to find the integral of 1 plus cosine square x dx by using a substitution of d equals to tangent x, right? So now, if you have this kind of substitution kind of question, so the first thing that you need to know is you need to change all this expression in terms of t and dt, and that's the first goal that you need to achieve. Alright, so okay, just differentiate dt with respect to x and you will get secant square x, right? Now we know that from here my dx is actually equals to dt over secant square x, and this basically means you can substitute this into this expression. And similarly, we would try to find cos x in terms of t. We know that t is given by sine x over cos x, and this would give us cos x equals to sine x over t. Right? So this, I think with all this we are able to proceed from here. Now what you need to do is just substitute in the expression given and see what can you do with it. Alright, so dt secant square x, and this would give us t square 1 plus sine square x over t square. This is just manipulation x, and what I will get is basically multiply with t square to the denominator and also the numerator. I'll get sine square x dt over secant square x, and I will want to multiply this in, right, and rearrange and see what expression do I get. So from here I will get secant square x t square multiply with tangent square x. Now don't lose sight of what is tangent square x, because tangent square is given by t, so it means you're on the right track. Alright, so now substitute in your t square. So we have t square plus t square dt. Factorize the denominator and you could cancel and simplify this expression to 1 secant square x plus 1 dt. Alright, now from here, now once you know that this is secant square x, right, secant square x, and you want to express this expression into t, when you think of secant square x, you have to think about this formula where 1 plus tangent square x equals to secant square x. Alright, this is how you relate your secant square x into tangent square x. Means to change this into terms of t, because tangent square x is your t square, right? T square based on this substitution. So always think, how do you express this? Unless you change this whole expression into terms of t and dt, you can't really integrate this. Alright, so that's the main goal. So from here we know that secant square x plus 1, if I were to plus 1 here and plus 1 here, this will become a 2, right? 2 tangent square x. So from here we know that the denominator would be 2 plus this is actually my 2 plus t square, right? So this would be t square dt. Right, now to integrate this, know that this is a quadratic expression, top is a linear, it's actually a constant, not linear, sorry, constant, and quadratic expression, you have to refer to your MF 15, or now is called the MF 26, right? So in your MF 26, you yield 1, you're given 1 over x squared plus a squared. If you were to integrate this, this integral would be 1 over a tangent inverse x over a. So from here I know that this is actually my square root, right? Square root a is actually square root. So what I'll yield is 1 over root 2 tangent inverse t over root 2, which is a. Now t, then change your t into terms of x, because initially this is in terms of x, right? So change, this will be square root 2 tangent inverse tangent x over root 2 plus c. Alright, so this should be your final answer. So leave it as such, and yep. Okay, please if you find this video useful, please do share with your friends who who have the same problem. Okay, I received this question from one of my student. Okay, thank you and bye.